the Arizona Signal Watcher DXing video blog. Episode 8, 6-meter Yagi Part 2, The Build.
So in the first video of the series, you saw the design and the rationale for the design of the antenna. So here is the beam for the antenna that the elements will attach to, and this is the main part of the construction. Now we see there's a hinge here, and that's because although this is really not going to be, say, a backpacking antenna, I did want this to be relatively easy to put into an automobile so that you could take it somewhere. Also, I wanted to make it a little smaller to store as well. I can't really put up permanent antennas where I live. So there's a hinge, and one board is shorter than the other. That's because I used two 4-foot boards, and I attached them together in the middle with a hinge, but then I cut one short, so I have 3 elements on the longer board and one on the shorter board. So I actually have a 7-foot beam, and this beam hinges. Now it doesn't fold quite all the way up because the thickness of the element supports, but you can see it does fold down to a fairly small size. For these supports, for the elements, well, I used copper pipe. Basically, the 6-foot segments of the elements will slide nicely into this copper pipe, and the driven element has a copper pipe that's basically split with insulating nylon to separate the two halves of the element. That's the dipole element. Now, as far as why I chose to make the beam for the antenna wooden, well, I wanted something with a nice flat surface so it would be easy to keep the elements all in alignment. Now, that's something that can be done potentially with PVC pipe. Also, PVC pipe, you can connect pieces of it together with a union, so again you can make something that where the longest piece is not the full length of the beam. For installing the hinge, the main thing to keep in mind is that you want to keep the 2 pieces of wood butted up against each other as tightly as possible. So you want to do that when you're marking the holes for the hinge. And this is a standard 3.5-inch door hinge. And you want to drill the usual pilot holes for whatever size screws that that hinge comes with. And another key here is that when you're actually attaching the hinge after you've drilled these holes, you don't want to put any of the screws in all at once. You want to put these in gradually so you can make any tiny adjustments you need before you tighten everything down. Now I'm using a hand screwdriver. If you have dexterity or strength issues, of course you can use an electric. The nice thing about the hand screwdriver is that you do have a little more fine control over exactly how far in the screws go. So again, you don't want to put these all the way in because small adjustments can be made that could be important to the overall alignment. So here we see all 6 screws in. Now I can make final adjustments. Note that there's also a board underneath the boom here that keeps the bottom of the boom flat at the hinge. And here we see the hinge fully installed. And then we see it edge on. We can see the boards are butted against each other well. And we have a nice flat surface there. I decided to make sure that the screws went in as deep as possible, so that means they actually stick out of the 1/2-inch board. You can trim those off with a rotary tool. The problem is that if you have a cheaper rotary tool and it doesn't have a lot of RPMs, you just don't get a very nice visual effect. And so you want to make sure that you have a tool that has the RPMs
to give that desired effect. Now you can follow the same principle here with the installing these sleeves with those brackets. Is you can keep those screws a little bit loose until you get them exactly aligned. And we see that the 1/2 inch diameter aluminum tubing fits very nicely into the 1/2 inch diameter copper sleeve. Now notice that one of the elements is actually very close to the hinge, but you don't want to make it right on top of it. And also note here the driven element, the dipole element, I have 2 clamps on either side, and then I've cut the pipe and put about a 1/2 inch gap between the 2 ends and installed nylon hardware to provide electrical insulation between the 2 halves of the dipole.
Okay, so as far as the aluminum elements, what I did was I bought 4 6-foot segments, and then I bought 4 4-foot segments. And the 4-foot segments I cut in half, and those will go on either end. Those are the 3/8 inch segments. The 1/2 inch segments stay as they are, except for the dipole element. That will have to be cut in half. And again, you'll cut the 4-foot segments of the 3/8 inch in half as well. Now, I'm not going to show doing that. The thing is that these segments slide very nicely through the sleeve. I'm a little out of room here, but what I'll do is I'm going to pull this forward toward me. And that's to illustrate one way that you can make sure that your copper sleeves are aligned correctly, and that is measure the separation between the elements on both ends of the 6-foot elements. And if those are equal, then you've got good alignment, then they must be parallel. And what you can do is, as you're making that adjustment, well, just go ahead and leave these screws a little bit loose on the copper sleeves, and by doing that, that'll give you a little bit of wiggle room. Just leave it just a little bit loose, and then if you need to adjust this back and forth, or angle that a little bit, you can angle it a little bit, hold it there, and then tighten up the screws that you loosened, and that'll let you make little precise changes in basically the angle of this line relative to the line of the boards. Okay, so let's take care of the feed point connection. Now, this is the driven element, so we have the elements coming in into both sides of the sleeve, but then they're separated by nylon hardware. And so we have these 2 screws here, machine screws, one that comes off of each side of the dipole. And we need to hook that up to an SO239 connector and make sure this is mounted in some way. And then we can plug our feed line into this, and remember, this is the bottom of the beam. Okay, so I have this small section of wire here. This happens to be 12 gauge solid wire. You could use a little lighter gauge than that, but I just happen to have some extra scraps from working on another project. So I'm going to solder this one end of this to the ground plane of the SO239, and then this is going to go via a lug connection to one of the feed points. Okay, so I've soldered a ring terminal on one end of this little short jumper wire, and now I want to solder this to the body of the SO239 plug. Now, the one downside here is that this takes a lot of heat because
because this ground plane around this flange around the socket makes for a very good heat sink. So I have soldered wires, one onto the to the main flange here of the SO239 connector, and then the other to the center conductor. I put some tape on here just to cover up some of the metal there. And so it's going to go like this, and I will attach here to the feed point with metal nuts. Now I don't want to use all metal hardware to attach this SO239 connector to the board. What I'm going to do is I'll have these plastic spacers in here, and those will go through each of these holes. Now at the top I can go ahead and use a metal nut because that's in direct connection with the metal surface here of the SO239. Now on the bottom I will use nylon hardware to attach this onto the top of the board. Okay, so I have these four spacers on here. Notice I also put in a couple nylon nuts here just to give a little more space. I wanted the nuts here to be the highest part there so that there wouldn't be any issues with being able to screw on the cable. So now this goes through. Okay, so now I have the feed point connected here, and I've got this attachment here for the SO239. Now I need to flip it on the other side and put in the screws from the bottom or from the top to make sure this really is attached. Right now it's just attached by friction. Alright, so this is what's going to be the top of the antenna. We see the nylon screws and a little spacer there. And on the underside we can see this attachment. It's quite rigid. I mean, obviously this is moving around, but it's a very rigid connection. And there are other ways to shore that up if it turns out that you need to, but this should probably work for most purposes. Now one other issue with this Yagi antenna is that although its feed point impedance by this design should be very close to 50 ohms, so you don't need a transformer in that sense, it's still a good idea to have some sort of, if not a true balun, at least some kind of a choke to prevent getting common mode currents on the outside of the braided conductor, which can basically flow power back into the shack and have other nasty side effects. And there are a lot of ways to do that. For this situation, I think we're going to go with a choke. And what I'm going to do, at least to try this, is that coming from the feed line, I'm going to have this cable, and I'm going to put these are ferrite cores inside a plastic case, and basically they snap on to a cable. You have to buy these in the right size. Okay, so this is a little hard to show, but what I'm doing right now is I'm balancing the beam with all of the elements in place to try to find the center of mass, the balance point. Because I want that balance point to be as close as possible to directly over the mast. And so of course by doing that we're increasing the stability of this antenna when we put it up on the mast. Now the center of balance here is almost right underneath these screws. And that makes sense because that's about the center of the beam. It's shaded a little bit because there are 3 elements on the 4-foot section of beam and only 1 element on the 3-foot section. But it's still pretty close to center. Now what we're going to do is we're going to build a structure here that's going to connect it to a mast, and we want that again to be as close to centered over the mast as possible. And if we go down to the front end here, the back end of the beam is off the table here, but the front end here we can see it is hanging there. It's not down on the table, so that means we're very, very close to the balance point.
We need to connect the mast to the boom, so I'm going to have a block to do that. Now I've drilled 4 holes all the way through the beam and the block, and then there are 4 other holes to provide pockets for the nuts underneath the 4 screws you see. And so bolts will go all the way through the 4 holes to secure the block to the mast. And then on the underside, I used a drill press and a Forstner bit to drill a vertical hole for the mast. This was a necessary exception to my typical hand tools only policy. The block here has some cracks in it, so you can see I've added 4 screws in pockets there to help keep this block from disintegrating. And here we see the 1-inch PVC pipe inside a union, and that fits exactly into that hole. And then I will drill another hole all the way through this for another bolt to secure the pipe to the block.
Alright, so here is most of the antenna anyway. It's set up on a tripod indoors, of course. It's nighttime, so I'm doing this indoor shot here. We can see that it's not exactly in a plane, but it looks actually pretty good. The deviations from that are relatively small. There's a little bit of a deviation in terms of the reflector element is tilted a little bit to the right from this point of view, but not too bad. And keep in mind, this is a portable, at least call it temporary antenna anyway, so that actually doesn't look too bad. We get a shot here kind of from above. We can see all the elements here. Now this is not set up exactly in full working order because it's not, the lengths are not all precisely adjusted. That's going to come later. I have done some preliminary testing to see whether or not it's going to be resonant close to the 6-meter band, and it is, with some little adjustments from the original design specs. In general, this is fairly sturdy. There is a little bit of a bow to it. That's not surprising. This is certainly not a perfect setup. One thing that one might do at some point is to shore up underneath this hinge, put a board here to keep this from bending here. But the reality is that one of the main advantages of using an aluminum beam is the fact that it'll be stiffer and not bend so much. But having an aluminum beam, then you have to be very careful about how you mount your elements onto the beam as well. And so this wooden structure gives you a little more flexibility in that regard. Alright, I hope you're looking forward to part 3 of this series, where we're going to set the antenna up outdoors, test it out, make any adjustments we need to for the lengths to get the antenna resonant at the proper frequencies, and then hopefully test it out on 6 meters.